Hi, welcome to a new session of Basic Electrical and Electronics Engineering. In today's class 6 under DC machines, we are going to see different types of DC machines. In our past classes, especially when we were dealing with Basic Electrical and Electronics Engineering, we have seen the basic operation of DC machine, the principle as well as the construction. Then we have derived the induced voltage in a DC generator. We have also solved some numericals in DC generator, and we have also drawn the open circuit characteristics of DC shunt generator. In today's session, we are going to see the basic difference between generator and motor and the basic difference between types of generator and motor. So when you are going into the details of the construction, we know that this is a DC machine, 4-pole DC machine, where the outer part is called as yoke and the windings are known as field windings, which are placed on the poles. So these are the poles you can see over here, and a pole shoe is nothing but aligned parameter like this, which does not allow the windings to fall from the pole to the rotating part of the machine. And the direction of the current is also shown over here on the 4-pole machine, and there is a rotating shaft where the armature, the commutator and the shaft rotates in the same direction. So the armature also we have discussed in our past classes, and also commutator which converts the alternating current to unidirectional current, and the brush contacts where we collect the current from the machine. So this is what we have learned in our past class under constructional details. Also, we know that the basic difference between DC generator and DC motor, where the construction is the same and working principle is also almost same, but the main difference is that a DC generator converts mechanical energy into electrical energy, whereas a DC motor converts electrical energy into mechanical energy. So the working principle, as I told you, is almost the same. What is the basic difference then? A DC generator works on the principle of Faraday's law of electromagnetic induction, which states that the motion of the conductor through a magnetic field causes an EMF to be induced in it. Whereas, in a case of DC motor, when a current carrying conductor is brought in a magnetic field and the conductor cuts the flux lines, a force acts on the conductor and thus torque is developed and the electrical energy is converted into mechanical energy. So in both the cases, cutting of the flux is the important part what Faraday has observed. Only the difference is that in case of generator, we have only a conductor which does not carry any current, whereas in the case of motor, it carries a current carrying conductor. So in both the cases of generator or motor, first the main flux lines is there because of the magnetic field, and in the case of generator a conductor is there, whereas in the case of motor you have current carrying conductor which has its own flux. So the interaction of the two fluxes results in torque. So that is the basic difference between the working principle of DC generator and DC motor. Apart from this, what we have seen in our past class, that the generated voltage is given by Eg is equal to phi P and Z by 16 to A. You can look into this derivation in our past classes. Whereas the back EMF is also given by the same formula, phi P and Z by 16 to A. What you need to know is the significance of the back EMF. So you please comment in the chat box whether you know the significance of back EMF or not. Later on we are going to discuss about the significance of back EMF also. Then the generated EMF, it is called in the case of generator, and back EMF it is called in the case of motor. And the direction of induced voltage is given by Fleming's right hand rule, and direction of motion is given by Fleming's left hand rule. So you should know what is the basic difference between Fleming's right hand rule and Fleming's left hand rule by looking into this diagram like this. See, in both the cases, the forefinger indicates the direction of the magnetic field. That is a first important part. Then, in the case of Fleming's right hand rule, the thumb indicates the direction of motion and the middle finger indicates the direction of induced voltage. Whereas in the Fleming's left hand rule, the main field is because of the magnetic field that is given by the forefinger, and the middle finger indicates the direction of the current carrying conductor. Then the motion is given by the thumb. So that is the difference between Fleming's right hand rule and Fleming's left hand rule. So you should remember in your mind that for generator we use right hand rule and for motor we used left hand rule. So that is the main difference between these two machines under a DC machine. Now, when you look into the different types of DC machines, so DC machines are classified as series machine, shunt machine, and compound machine. First, we look into the DC series generator, where you can see rotating part of the machine is connected in series with the field winding. This is also in the motor. Also, you can see the rotating part is connected in series with the field winding, and the current, it is armature current or series field current or the load current. It is one and the same in the case of series generator, and in the case of motor also, the armature current, the series field current and line current is almost same. Now, in the case of generator, the energy is liberated and that is being utilized by the load. So here the load, it is we are treating the voltage across the load as terminal voltage, and motor needs input supply. So here the voltage becomes input voltage. So that is the main difference between these series machines. That is the generator, you have the terminal voltage. In motor, you have the source voltage. So you can see the direction of the currents, where EG, the generated voltage, is almost supplying the load, whereas motor is taking input as V in, and from it the line current is traveling into the series field winding, and then it is going to the armature of the rotating machine. So we already know what is EG and EB. Now the resistors of armature is known as armature resistance. The series field winding has series resistor, and since it's a series circuit, current remains the same. So that is the first important equation in both the types of machines. Then let us apply KVL in the closed series circuit as shown in this particular figure. You can see minus EG plus IARA, that is a drop across the armature, plus ISC RSC, drop across the series field winding, plus the terminal voltage is equal to 0. Whereas applying the KVL in anti-clockwise, I'm going to get minus V in plus ISC RSC plus IARA plus EB equal to 0. So we are going to get here EG is equal to armature current times resistance armature and as the series field winding resistor, both combined, because the current is flowing the same, that is why IA is taken outside, plus VT. Whereas in the case of motor, we get V in is equal to EB plus IA of RSC plus RA. So that is the main difference between the formula when you look into the terminal voltage or when you look into the input voltage for both the machines respectively. So these two formulas are very important. So what you need to keep in your mind, that in the case of generator, the IL is treated as load current, whereas in the case of motor, IL is treated as line current. Okay. Now when you look into the generator, shunt generator, you can see EG is developing its voltage and it is delivering the current as IA to the parallel paths, that is shunt field path as well as the load path. So the EG voltage value is delivering its current through to this both parallel winding circuits. So one you have the load and other you have the shunt field winding. Likewise, when you look into the shunt motor is taking as input as V in, right? So EB is the back EMF that is obtained because of the line current. So the important part of both these circuits resembles in the armature current in the case of generator is equal to shunt field current plus load current, whereas line current in the case of motor is equal to the shunt field current plus the armature current. So that is a basic difference between these two machines. And the shunt field current in the case of generator is given by terminal voltage by RSH, whereas the shunt field current in the case of motor is given by V in by RSH. Okay. When you apply KVL in the closed circuit over here, you can see EG is equal to IARA plus VT, whereas applying KVL in anti-clockwise direction in this circuit resembles V in is equal to EB plus IARA. So the same thing you can apply for compound machines, and comment in the chat box whether you are able to Derive the equations between generated voltage and terminal voltage in the case of generator, whereas the relationship between the input voltage and the back EMF as well as the current conditions in the case of compound motor. So that's all for today's class. I hope you like this particular session. Please share among your friends, subscribe to this channel, and please press the bell icon for future notifications. Thank you.